So hello again, everybody. I'm sure the title of this video has you interested, intrigued, possibly concerned. But I'm here to explain, because after going through years and years and years of videos and working with and running these HEI conversions on a 20R Toyota, I have a lot of information now, and I've just discovered one last very important piece. It's minor, but it does make a big difference, so bear with me. I will explain. Yes, some of these setups do need a ballast resistor for the ignition coil to run correctly. Here's the situation. When I first did this, I took a lot of advice that I found, etc., etc. I was told that the HEI module would work with the original coil for the 20R. And this is basically true. It will work, it will run. But what I've found is the idle quality is mildly inconsistent. You'll hear surges every now and then, or feel surges every now and then, and it's small, but it's there. Under throttle, it runs good. But what seems to happen is running those coils on full 12-volt battery power, and by that I mean running battery voltage. The voltage you're getting from the alternator. It's minimum 13.5. It can be as high as 14.7. Now, the original coil style for the 20R from, if I can find it here, 75, 76, and 77 had points distributors. So they had a ballast resistor, of course, because you don't want to run a bunch of current through your points and burn up your points and have to be replacing them every 1,000 or 2 miles. Plus, and something nobody ever tells you, these older style coils, they don't necessarily have to be the can style, but usually they are, used with external resistor. Even when Toyota switched to their igniter electronic system in 78, and also used it in 79 and 80 on the 20R, okay, even the igniter was still carrying a ballast resistor. That's because these older coils were not designed to continuously run on the full 12 volt plus running battery voltage. I've had these coils go up within 5,000 miles, brand new coil, as you can see, standard. This is the UC12. It's a good coil. It's great quality, comes with a good warranty, and by the way, if you're looking for coils, always get quality. Make sure it's got at least a 1-year warranty. Don't go with a 90-day or 6-month. Go with a year plus. There's ones out there with 3 years, better quality. The primary winding was never designed, originally designed, to work on constant 12 volt plus. It just wasn't. That's why, again, you need a ballast resistor. It drops the voltage down to about 8 to 9 volts. In my case, doing the measurements and everything else, it runs about 9 to 9.5. It makes your coil last longer, run cooler, less stressful in the coil. Why is this important? Because I have recently done this, got a ballast resistor in the circuit with one of these coils, brand new. The idle quality is so much better and so consistent and so smooth, I can't believe the difference. And I've actually heat tested the coil. It doesn't get as hot as it used to. It runs fairly warm, but not hot. You can keep your hand on it for a good 10 seconds, no problem. The old one, full voltage, put a finger on it, you could hardly hold it there for a second or two. It got so hot. So that's the deal with that. When Toyota went to the 22R, they changed the coil style and they changed the spec in the coil. These 3 years, I mean, there was a whole transition changeover happening at the time with all the makers out there. Toyota was still experimenting with it. They still ran the ballast resistor because they thought it was just better. But once they got a little bit better tech on the coil and they were able to build the primaries to actually handle the higher voltage, you no longer needed that ballast resistor because the coil could work at full running battery voltage. This means the coil can now provide better spark than before. I know it doesn't sound like a big difference between like 9 and 12 or 13 volts, but you know, quite frankly, that's a 25% or more difference. Now, related to that, hopefully you'll be able to see this. Here's the coil specs. As you can see here, 75 through 79, the primary was rated at 1.3 to 1.7 ohms. Primary resistance. They dropped it a bit in 80 to about half of that, even though they were still running a ballast resistor on some of these. You can see by 81, when the 22R came about, they settled on 0.8 to 1 ohm. You can see it's a lot lower. The HEI modules, all electronic ignitions, they're all transistorized, they all work on power resistors, they all basically work the same. These things like primary coil resistance to be a lot lower, to be happy and live a long time. If you know anything about Chevy brought out the HEI, I think in 73, 74. This module in particular, the 4-pin. And those coils had this lower primary resistance. A lot of those modules lasted 20, 25, 30. I even saw one guy who had one in a Corvette with 67,000 miles. And the module was 40 plus years old and still working just fine. Which you would expect for 67,000. But, you know, age, no big deal. But here's the difference. It's the primary resistance. Now, how does that jibe with putting a ballast resistor in and actually increasing that initial primary resistance? Well, it doesn't seem to matter. Because, again, the coil's working less hard. And that seems to be the key. The module just switches the coil on and off. It's all it does. It switches it off by the negative terminal. Whenever it turns it on, it charges the coil. It turns it off. The coil discharges through the wire to your distributor cap, which then goes through the distributor and makes spark at whatever spark plug it's pointing to. So that's not an issue. So just for the heck of it, let's go to secondary. See, the secondary was 6,500 to 10,500 for 75 to 7920R. They increased this for 80. And you can see they maintained it for the 22R in 81. Then they backed it down a little bit for the next 6 years, 82 to 88. Okay, this is still higher than this original spec. This is still a quote-unquote hotter spark than what the 20R was getting. Make sense so far? Hope so. If not, ask questions. I'll be here. So here's the point. This lower ohmage matters. Yeah, fine. But the lower primary ohms has to do with, again, that difference between 9 and 12 volt plus input into the primary. What's the difference? Okay. And we'll come down here. Here's the 78 coils. Here's the standard UC12 that I use. Nope, that's not it. Sorry. Here we go. As you can see, it's the usual can coil. Used with external resistor, 803. Yeah, 803, that's the one. And see down here, it's got a 36-month, 36,000 mile warranty. It's a quality coil. All right. But then we come up here to 81, 82. Pardon me while I find it. There we go. 1982 ignition coil. You can see that they've all changed to these brick style. Okay. It's got an iron core around it. It's got a small sort of can in the middle, and this is filled with epoxy. The old can style ones like this, pardon me for knocking it around, is filled with oil, which acts as a cooling lubricant, I guess you could say, and transfers heat out through this steel case. All right, these older epoxy ones, they can operate at that higher 12 plus volt running voltage, and the epoxy can dissipate the heat out through this exposed iron core. It's actually like a big heat sink. Okay, whereas basically this metal can is the heat sink on the old style. But that's the difference between them. You can see nobody's offering the old can style anymore. Wells makes a nice one. That's basically what it is. It's just got the 2 tabs, input, positive, negative. It works exactly the same way. But with these newer style like this, you can run full running battery volts, 12 volts plus, that 13.5 plus. With these older style coils, you can't do it. Now, if you're not confused enough, again, you can ask me questions, no problem. You can do the conversion with these older style coils, but you need to put in a ballast resistor. And if I remember correctly, RU4, boom. Standard makes a resistor, and so does many others. Standard motor parts, part number RU4. Here's one from Summit. We'll just look at that. There you go. Looks just like this. Okay, you can see, cheap. This has a rating of 1.4 ohms resistance. Okay? I put that in line in the run circuit. And I'll be going outside and show you the difference between run circuit and the start circuit, because there's another point to that. Sorry if this is going to be long, but hey, got to get this information out. It drops that 12 plus running voltage down to about 8 to 9 volts. In my case, it's about 9.5. That's a big deal. Here's why. 9.5 divided by 13.5 minimum alternator output. 0.7 difference minus 1. That's almost a 30% difference. Yeah, I'm losing 30% of my ignition power. Trust me, it's not a big deal. You don't need it. This old style coil will give you all the spark power you need to run it normally as a good driver with good power. This is not about a performance engine. This is not about a built 20R performance engine. This is about standard, stock. Okay? Yes, it's not going to apply to performance. You're going to want to do something different. Fine. This is about stock conversions. This also applies to Celicas, Coronas that have the 20R. It's the same setup. I've heard from a lot of you Celica guys out there from 78 and previous. It's the same setup. Same electrical system, same motor, same coil. Okay? So, it just runs better at that lower voltage. And this is what will provide it if you have this wired into the run circuit. Okay? The start circuit's a different story. You want the full battery voltage to start it because you want to start it quickly and just get it going. That has to do with something else that I had to find out about, and it's not even commonly known. Back in 78 and previous, well, 80 and previous maybe, when ballast resistors were still being used, your starter on the 20R has something interesting about it. Starter motor. And if you look at the listings here, you can see this. With R terminal, without R terminal. Okay? Direct driver gear reduction, it doesn't really matter. They either have an R terminal or they do. Alright? These pictures are, I think, the same. Hopefully this will show up. Okay, see this wire coming off of here? That's your trigger wire from your start circuit from your ignition switch. Okay? Right across on the other side, there's usually a little tab here. Let's see if I can get a decent picture of it somehow. It's hard to pick up on some of these pictures. But trust me, it's there. There's that little tab right here. Okay? It's supposed to be a 1/4 inch spade plug that goes on there. And a wire goes over to your ignition coil plus. Direct wire. When you start your vehicle, the solenoid closes, the contacts close. Full battery voltage, whatever's in your battery, which by the way should be at least 12.6, 12.7 if you have a good battery, goes straight through and straight through to your coil. As soon as it starts and you let go of the key and the ignition switch flops back to the run side, that's when the run circuit takes over and the ballast resistor takes over on run. Okay? Hope I'm explaining this clear enough. But, you know, again, if it's confusing, let me know. Be glad to explain it. That looks like the same picture. Yeah, it is. But you can see the tab there. There's the tab for the R, the run circuit. And that says it's without it, but it's probably the same picture anyway. Oh, it's not. Cool. I love discovering this stuff with you guys. Yeah, see how there, here we go. See how there's no tab on this side anymore and no wire? Okay, that's just got the single tab here, and that's where your trigger wire from your ignition start goes to. Okay, this is for later models that don't have the ballast resistor. Simple. So, just so you can get a good visual, I think I've shown you everything here. Oh, here we go. The typical wiring. As you can see, 4-pin. B for battery power, C for common. It goes to the negative on the coil. These two wires are from your distributor that have the electronic pickup coil in it, not points. You got a G and a white. White wire goes to white, to W. Red or pink wire on Toyota distributors, 78 or newer. Yes, even 22R distributors will work with this. Goes here, red or pink wire. This polarity is important. You need to get that right. If you turn it the other way, it may not run right or it may not run at all. As always, big deal. This tab right here, a little hard to see, but you see how that you got a tab on this hole and not this one? This is the ground. This has to go to a really good solid engine ground, frame ground, solid clean body ground. These modules need a good solid ground to work correctly. Okay, I've talked about the heat sinks before. I'm not going to talk about that. You want to know? Ask me. Look at my other videos. You still don't know? Ask me. No problem. I can tell you what I recommend. Because again, these things need good heat dissipation to keep living and have a good long life and function properly and not break up. But basically, this isn't going to show you about the ballast resistor. You need to have the ballast resistor in the run circuit, not the start circuit. This is oversimplified, but again, I'm just putting it here just for reference. So now, I want to take you all outside and show you what I've done and what it looks like, and it will make more sense, hopefully, so stand by. Okay, so here we are. Here's my current setup. All right, starter's down here, buried down there. See this nice new piece of wire loom I have here? I've got a single wire in this going to that R terminal in that starter and going bouncing over and over to here. All right, it's got one wire coming out. Fix that tape. It goes straight to the plus terminal here. Okay, that's only active when it's cranking. That's what that R terminal does. It sends power from that terminal, and you have power when you're cranking full battery power. Once it starts, that circuit goes dead. Here's a plug here in this harness. Most 22Rs are going to look like this. Doesn't matter what the model, pickup truck, Corona, the Celica. This is the original hookup for the igniter. Both of these have power when it's on run. Okay? I've got one wire here coming off, and it goes to the B on the module. Alright? The other wire I've got going to the ballast resistor, now, which was the point of this whole thing. Now I know this may look a little confusing. These also have power when it's hot, but I just want to get this all separated. Okay? Because again, if there's no power to this when you're cranking, it's not going to start. But here's the thing. Run circuit here. Definite run circuit. It's got battery voltage, alternator voltage when it's running. Right to here, to this side. Resistor drops the voltage to 9.5 and it goes straight to the positive. Okay? I understand it's a little confusing, but it always is. In any case, there you have it. I used to have just using these two for power, and it was getting full battery voltage all the time. This way I can drop it to 9.5 to run this instead of the 13.5 minimum coming out of the alternator. Alright, so hopefully seeing it makes a little more sense. In, out, in. You're trying to come off, get up there. And again, straight to the center of the distributor. Red, white, or white, pink. There's the two wires there. I've got them over here. I use green extensions just because, for the heck of it, because it's G. And the heatsink, it's an AC Delco modified. I've cut one of the fins off here so I can mount it this way because I didn't want to mount it the other way. I'm rambling now, and this video is going to be long enough, but there you go. Yes, running a ballast resistor on this with the original style and original design coil makes more sense. It runs better, your coil lasts longer, your module lasts longer. Of course, I only use the LX301 by standard. The T is just as good, costs a little less, but I just decided to go with the best one they had. It was starting to break up because of this coil getting hot. It was making this work harder to switch it on and off, creating extra resistance. So you'll save your module, you'll save your coil, the vehicle will run better, coil will run cooler. You won't develop hot start problems later, or idle run quality problems or run quality problems. It's worth doing. Again, if you go this route, just get a quality resistor, like the RU4 from Standard. AutoZone has their Duralast one, which is made by Wells, which is also really good quality. They're about $10 a piece. I do not remember the part number offhand. But if you look at it long enough and look at the pictures close up, the two little tabs that are on the resistor, one of them is actually stamped 1.4, and that's how you know it's the right one. Okay. I've had a lot of other things going on with this truck, including a brand new rag joint down there, which was a tremendous pain in my caboose. I did not film it, sorry about that. But it did take care of my steering problem. I was having some wandering problems, and steering wheel play was like 2 3/4 inches. It should be 1.5 inches or no more than 1.5 inches. It's back to that now, thank God. The wander's fixed. Fixed all the front end on it, all new parts. Basically rebuilt the entire front end. I still have a long promised carburetor tuning video I need to get to you, and I'm going to need to do that as a sit down. And I can't show it to you because I've already done it, and I'm not going to do it again live. I've been trying to find a way to get it recorded. I just couldn't do it. There's been too much going on. I mean, Radiator hose was swelling. I had to get a new one. The front oil seal was leaking because I replaced the balancer and that goofed up the oil seal. That's my fault. Got that replaced. New oil pan gasket. That was a pain. It's always been something. Hopefully I'm done fixing for now. But there you go. I want to get this out there for anybody looking for it. Again, if I'm not clear, if it's confusing, write me. I will try to be more clear in an answer. It really is simple once you get down to it. I will help you get yours fixed as well and get it running good. All right. Thanks again for watching. Thanks to all my subscribers who hang in there with me. God bless you. Wouldn't trade you for all the money in the world, and I mean it, okay? Really appreciate it. See y'all next time. Bye.